Let me read out the next question here. Calculate the EMF of the cell, and they have given the cell representation here. The cell representation is nothing but the left hand side is written with a word as anodic reaction where oxidation will be involved, and the right hand side we are going to write the cathodic reaction where reduction will be involved. And they have also given the electrode potentials for chromium as well as the striated electrode potential for iron is given, and they are asking us to calculate the EMF of the cell here. So we have to use the Nernst equation here. Before using the Nernst equation, let me write this half cell reactions for chromium and iron. You have to observe here chromium from 0 oxidation state to +3 is involved, which means that anodic reaction is present. So let me write at anode. At anode, chromium, which is in a solid state, is undergoing for oxidation, that is with a loss of 3 electrons here. And at cathode, Fe2 plus aqueous ions with a gain of 2 electrons, it is undergoing for reduction reaction here. To balance the number of electron in both the half cell reaction, I am multiplying this 2 by for anodic reaction and this 3 electrons for cathodic reaction. Let me write the overall cell reaction now. Overall cell reaction, that is chromium, 2 chromium plus how many Fe? 3 Fe, 3 Fe2 plus, and here it is 2 chromium 3 plus 3 Fe aqueous ions, and this is also aqueous ions. So the number of electrons involved, here it becomes 6 and here also it becomes 6, so both will get cancelled. So the number of electrons involved in this reaction will be N will become equal to 6 here, okay, because 2 into 3, 6. Now for the calculation of Nernst equation, to involve this Nernst equation here, we have to calculate what it is standard electrode potential, that is E naught cell we have to calculate. E naught cell is equal to E naught of cathode minus E naught of anode. We have already have the values for cathode and anode. Cathode is the one where reduction will be occurring. Which is undergoing for reduction? Fe is undergoing for reduction. The value is minus 0.45. And what is anode here? Anode is the one which is undergoing for oxidation here. Minus of minus 0.75, which becomes minus 0.45 plus it will be 0.75. Okay, so it will be 0.30, right? It will be 0.30. So now we have to calculate. We have got the value for E naught cell. Now we have to calculate the EMF of the cell by using the Nernst equation. So let me write that one here. E cell is equal to E naught cell minus 0.059 upon N log of we have to write the concentration of oxidized by reduced here. Concentration of oxidized ion is chromium 3 plus, but you have to see chromium 3 plus. How many chromium 3 plus? 2 chromium 3 plus is there. That power we have to write here as a square. And reduced ion is which one? Fe2 plus. And how many Fe2 plus are there? There are 3 Fe2 plus, so it is cube here. Then we have to substitute the values of concentration here. Now E cell is equal to E naught cell, we have got the value as 0.30. 0.30 minus 0.059 upon N value is 6, and log of concentration of chromium 3 plus is how much it is? 0.1. So I'll write 0.1 square, and here it is Fe2 plus is how much it is? 0.01 cube here. 0.01 cube. Now let me calculate the values here. It is 0.30 minus 0.059 upon 6, and log of, let me write these values as 0.1 as 10 to the power minus 1. So it will become 10 to the power minus 2. Okay, 10 to the power minus 2, and here it is 10 to the power minus 2 cube it is. So it is 10 to the power minus 6. Now E cell is equal to 0.30 minus 0.059. I'll keep it as it is. Log of this 10 to the power minus 6. When it comes to the numerator, it becomes 10 to the power plus 6. Plus 6 and this minus 2 becomes 10 to the power plus 4, right? 10 to the power 4. Now we have to calculate this log 10 to the power 4 here. Let me calculate here only. Log 10 to the power 4 is equal to 4 into log 10. Okay, 4 into log 10, which is nothing but log 10 is 1, so it will be 4 here. So now E cell is equal to 0.30 minus 0.059 upon 6 here into 4 it is. Okay, so now we have to calculate the value for this. So now for the easy calculation, what I have to do is that 0.30, this is 0.059, I'll take it as, I'll shift the powers here, that is 0.05959, I'll take it as a 6 so that it will become easy. I'll shift the 0.12 over here. So it is 6 into 10 to the power minus 2 into 4 by 6. So that I can cancel the 6 and 6 here. So now this will become 0.30 minus 10 to the power minus 2 is there. 4 into 10 to the power minus 2 is nothing but 0.04. So the answer is 0.26 volt becomes the answer for this EMF of the cell. The EMF of the given cell is 0.26 is the answer.